Well, hi, good morning. Welcome to my shop. Thank you so much for joining me and my cat, Peanut, who's decided now he's had enough already. This is not what he wants to do. He wants to go down. Okay, Peanut. Okay, you're going down. Okay, I'm gonna have to, we'll have to try this again. Okay, let's try it again. Hello, good morning, and thanks so much for joining me in my shop here on December 5th. My cat is now upstairs eating. He wanted food in his bowl. Okay, that's out of the way. Now, a couple things about this radio. In the last video, when I was testing the radio, I encountered a very powerful interference noise, or pulse, kind of, that I'd never heard before. I did track that down in my house, and I won't go into details, but it has to do with a battery-operated backup power system I have in my garage, and I had drawn it down to the point where something was turning on and off like this. And that's where that noise was coming from. Yeah, really coming from the inverter, I'm pretty sure, that was turning on and off. This is a 12-volt backup power supply. So that's good. I'm glad I figured out what that was, because a terribly powerful interfering noise throughout my house from that. Okay, that's done. Now, I have a choice here. I could continue with sort of the improvement of the operation of the radio by doing an alignment, and maybe a couple of other things here and there, or I can turn my attention to this mysterious meter. Mysterious because I haven't been able to find too much information, or I found no information about the meter being mounted on the front panel here. So, but I have found some information about the meter. Thank you very much for the article that was sent to me by Robert, I think it was. But I also, in the article that Robert sent me with a little bit of a description about this meter, it also came with a diagram, basically the same diagram that's in the manual here, minus this part. The pilot light part is not shown. Just the meter. So this is an unusual way for a meter to be connected, in my experience anyway. Maybe not in other circumstances, but it's connected. The meter is connected between the screen and B plus on one particular tube, a tube that's about halfway through the radio or so. The idea here is B plus is a fixed voltage in the radio. The screen voltage at the tube is going to vary with the amount of current flowing through the tube, or the amount of current flowing in the screen circuit, since you're picking it up at the tube and there's a screen resistor or resistance in the circuit. So more current in the screen causes a drop in the screen voltage. That increases the difference between the B plus and the screen voltage. So, so when the radio is working hard, the screen voltage is dropping, the difference is increasing, the meter is deflecting. That's kind of how this is working. Then over here we have a voltage divider. Although it says 20 M, the M actually means mille in French, which is 1,000. So the M actually means K by my modern notation. So you got 25K, 10K, and a 20K voltage divider network, and you're moving up and down in this component here with the adjustment. And that's got to be zeroing out the difference between the screen and the B plus that may be there during just normal or no signal operations. With no signal, there may still be a difference here. So this compensates for it, I'm pretty sure. And there you are. Current flowing through the meter is being robbed from the screen. Screen current. I think. And maybe that's not a correct way of putting it. So now this diagram doesn't show you. Just shows you this. This is the plug on the back of the radio here. This plug. It says right on it, meter, right there. So this plug exists. I have it. What did I do with it? I've put it, this is it here. It's wired up to this cable. And the cable is here. Why would somebody do that? Why would somebody cut this when they could just pull the plug out? If the reason it's cut is because there's something wrong with the circuit that was inhibiting the operation of the radio, then why don't you just pull this out? Somebody with a pair of cutters didn't recognize that this was a plug that could be pulled out? Or there's something wrong and serious enough that if you left this hanging in the back, someone like me would come along and go, hey, let's plug that baby in. Plug it in, and that might be the end of something. Maybe. I don't know. That would be one reason why, one rational reason for cutting this. It's a mystery to me what has gone on here. I'm going to guess that if I were to take these colored wires down here, it looks like there's 4 or 5 of them in here, and just hook them back up, color for color, that this would be restored to the way it was intended to be, and the way it once operated. We have to assume this once operated properly. Why is it cut? Cut by accident? Somebody has slammed a lid on it and cut it? I don't think so. That's a pretty heavy cable to cut by accident. So that's a real mystery as to what is going on here. If we look at the meter, I decided to work on the meter today. If we look at the meter, it's a pretty, I don't know what to call it, slapdash arrangement here. So here's the big cable coming in, and it's quadrafuricated right there. There's 4 wires. The wires are supported in these rather overdone supports here. One here, and that's the one support. This is a light socket for a light in the back of the meter, and I'm pretty sure the light's not working, so that's something we're going to want to take a look at. And this must be the feed to the light, and then there's a very large resistor here, and the light is fed from the white wire going into the cable. I'm going to put colors on here in any way, but I don't know where this cable come from. How'd this even get in this radio? Was it a kit you could buy and you could pop out the speaker? And if that were the case, then the speaker would be roughly installed in the lid, and we would see that. We would see that. Let's look at the lid here. That would be nice to know if this was done in a factory or... So these are the speaker screws. And there's a whole plate up in there. The speaker is mounted on on rubber mounts that have shrunk. Well, these are hard like a rock. So we should probably do something about that. Only screwed in two sides onto this plate. Well, the plate is screwed to the grill. So the grill doesn't show any sign that it was, you know, it's not a special grill area here or anything. It's just a regular top. Well, I don't know. I think the question remains unanswered. Did somebody do this as a kit afterthought to their radio? Don't know. Don't know. Okay, so if we look at the size of some of the resistors which are visible in here, you see this one looks like it looks like a 2200. 2200, that'd be a 2.2K. Wow, there's nothing here like that. 20K, it's close. And this one up here, well, this is a red, yellow. That's 220K. That's nothing near these. Wasn't expecting that. I took a peek at this last night, and I thought, oh, there they are. Yeah, those are the right ones. This resistor is an odd type of resistor compared to everything else in this radio. So we have the variable resistor. It's got some resistance in it. You can read the number 10 right there. I might say 10K. I'm not sure what it says there. 10.60 or something like that. I don't know what that is. It's supposed to be a 10K according to this. The slider should be going over to the meter. The slider is going right to the meter. The other side of the meter movement is leaving on a wire that's going out the cable. The other side is leaving on a wire going out the cable. Supposedly the position number 4, it's the negative side of the meter. It's connected to the screen grid. I have another diagram to look at. Let's stop and do that. Okay, so here's a look at a fairly recent magazine article, and thank you very much, Robert, for sending this to me. This is quite interesting to look at. There's the radio I'm working on. There's the speaker mounted in the front panel. But if we just go through this a little bit, let me have this out of order. There's a page. There's another page looking at the back of the radio. The speaker, again, right in the front. That's the first page again. And there's a diagram we're going to look at in just a moment. But let's go back to this one here that has this photograph, because there's something quite interesting in here. This is a fairly good photograph and reproduction. If we look down here where that filter capacitor is in my radio, filter capacitor is connected from one of these terminals over to this grounded terminal here. It's actually bridging right between here. But there's no capacitor here. In this radio, the capacitor's been located here. This is the replacement. He's used orange drop capacitors, and he's got it, well, it looks to me to be across the line here. There isn't any capacitor going to the cabinet here that I can see. He's forsaken that. That's what it looks like here. I read this article, of course. The fellow knows what he's doing, and he doesn't comment anything about this at all. It's just here for me to see. Did he remove the original one that was here and decide to put this in? I don't know. That's interesting though, because I still haven't made permanent what I'm going to do with the radio I have. So, well, clearly if this guy thinks this is a good option for him, it's probably a good option for me too. Okay, now we'll go look at the actual meter. Here it is here. Let's just rotate it around. So what's different about this diagram is it actually shows you where you're getting the screen voltage from. It's tube number 3, pin number 6. That's the screen of tube number 3. In the article, it mentions that in earlier versions, they used a less sensitive meter and had it connected to a collection of screens, so the screen current was adding up. There was more current. So instead of it being this looks like it says 0.1 milliamps, which is a 500 microamp movement. It looks like originally this was a 1 milliamp movement. But in my radio, well, I can't tell for sure yet. Probably it's the single tube V3 version here. I can't say I found any written information that fits the radio I have on my bench perfectly. Okay, so that's great. Now, what are we going to do next now that I've sort of sorted things out? Should I just put that plug back on? Just wire the plug back, color for color, and then stick it in there? What about this crazy speaker wire deal here? So this stuff, these wires, this stuff has nothing to do with the meter. This is somebody's attempt at creating what? What have they created here? They've got a pair of wires here and a pair of wires there. There's a rather odd switch arrangement, which this is not something you whip together. What's going on here? Could be if you did this modification, you were also encouraged to do this if you did the meter modification, you were also encouraged to do the speaker modification. But you'd only do it if you had an interest in hooking up an external speaker. Like me. Well, I don't know. I don't know what's going on here exactly. Okay, so good time to drink some coffee and think about what to do next. What would be the smart thing to do next? Okay, gave that a little bit of thought. First of all, what horrible thing could happen? What could be the horrible thing if I were to just hook these wires back up, plug that back in, turn the set on? Well, short circuits come to mind. What if there's a short circuit, maybe in the wiring or something? There's a short circuit, and you'd have, well, you can have different short circuits here. The pilot light here in this diagram must be the light that's right inside the meter. This shows a nice big resistor on it. It's definitely part of this cable, though. So what's a great big resistor doing on it? Isn't this a 6-volt light running off the same 6 volts as the tubes? Well, that could be part of the picture right there. Now I can easily interrupt the light circuit. You just pull the socket out. Pull the socket out. Oh, what's going on here? Oh. So this resistor and this wire, which is hard for you to see, but there's a wire coming down here, they're soldered to the outside of this. And on here we only, oh, okay, here we are. So one wire is a B- wire coming to this socket. That's the socket. Then the other wire is this one with the resistor here, which I can, oh, you know, it could be 22K. That could be red, orange. Yeah, you know what? I think it is red, orange. So you got 22K here. I think it's 10K for the potentiometer. And then the top resistor, 25K. Well, it could be because this is 22K. Okay, so these are working out. This is working out. This terminal on the meter is unbelievably close to the shell of this. There's like a millimeter clearance there, but there is clearance. I'm looking for short circuits or something like that. So what if the meter movement is burned open? Well, then there's no consequence. Plug it in, nothing happens. Big deal, the light comes on. That's the end of that. What if it's shorted? I don't know how you could short one of these, but if there's a short in there, both these terminals are very close to this. Close is okay though. Well, if you had a short, you would then have a short between B plus and screen, excuse me, with a 22K resistor in between. I can't see, the screen voltage and B plus are going to be very close, hopefully very close. It's hard to see what kind of disastrous thing might happen if I just wire this back up and plug it in. It's really hard to see. And how about wiring it up and plugging it back in? Nothing bad about any of these. The other end of the cable is kind of a ridiculously long cable. Why, if this were a kit, why wouldn't it be wired right into the set? Why would you still want to use this? And I don't know the answer to that. That sounds like just a decision somebody made somewhere along the lines. Oops, looks like I cut into a wire there. They're the same wires, and they have to be the same. Except I've damaged one there. Okay, that's a little better. Well, I don't see any reason I shouldn't just restore this back and plug it in. Okay, that's what I'm going to do. I'm going to put that cable back together and we're going to see what happens. Okay, there we are. Not the best job, but good enough. Now, what is going to happen? So, let's see, I should plug that in. I'm going to need a good strong signal to test its effectiveness. So when I was showing you the picture of the other fellow's radio and it had the capacitor across the power line coming in, I didn't make the point that I was heading for. I got distracted. The point is that what was going on with the sensitivity trouble in this radio? In that early on it seemed to work pretty good, and then it didn't, and now it does again after replacing that critical capacitor. That critical last capacitor was tied to the chassis. And that, the critical capacitor that was up in the front end of the radio, that was seemed to be sucking the life out of the radio. That is connected to the chassis. That's the same place that the filter capacitor, the line filter capacitor, is going down to the chassis. Now, could it be that when I reversed the plug, the behavior of the radio changed a lot, and I didn't notice that? With the plug in one way in the outlet, this is the unpolarized plug here, the result is the radio worked well, and the other way the radio did not work well. When it's plugged in here, the situation is different again. This is an isolation transformer, so you cannot find a ground this way. So I don't know. That's an interesting question. Maybe we can look at that later, because the capacitor I put in is still in temporary. I've still left the unpolarized plug here. Okay, is there anything else that could go wrong here? Well, there could be a ground in here somewhere that shouldn't be there. And that might present a very serious problem to the radio. So let's just look for some very low resistance that might just be a problem here before I plug this in. Okay, clip lead. So I'm going to clip one. I'm going to clip one lead, this lead, to the chassis. Go right here. Okay, and we're going to check the meter. Okay, are any of these guys going to report a 0 also? I wouldn't be surprised if one of them does. None of them. Let's put it up here. This is 6 megohms. Now we're probably going to see some action. See some action. Action. Stuff happening here. Look at that one. Whoops, I missed. None of them. That's a little odd. I would think something here would show up like the outside of this. It's showing on the B minus, isn't it? This is a B minus line. Oh, I don't have a plug yet. Plug in. Okay, set is not on yet. Not even plugged in. Okay, now take a look. We should find a 0 happening here. And we got a 0. But we should not find a 0 happening here. I say here. Or here. Either side of the meter doesn't show a 0. Good. And there should not be a 0 here. There should not be a 0. There should be a 0 here. Okay, you know, it's all adding up. At least it's matching what's in my head. That's about all I have to go with here. I think we're good to go. I think, could this be a case of somebody cut that wire without having a clue what they were doing? It's just a completely clueless cutting of the wire. That's kind of hard to believe too. Okay, great. Well, time to have a little coffee before I turn on this beast. Just in case it's the last thing this radio does. Okay, wow, I got sidetracked by a phone call from a guy with a stereo. Can you help me? So we're going to use the dim bulbs to protect things because I really don't know what's going to happen for sure, but I think everything's going to be fine, really. But we're going to keep our eyes on the dim bulbs here. I've got 2 of them in. I think one is just not enough for something this big. The switch is on. As soon as I hit the power switch, it's going to come on. First thing we should look for is light behind here. The bulb could be burned out, so maybe that will mean nothing. We have this adjustment here, which I'm going to put in the middle. That sounds like a wire wound resistor. Okay, sounds like it. I've got the signal generator running at 1,000,000. I've got the radio tuned to roughly 1,000,000. I'm on the broadcast band. We're here, red, 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 red. Everything's ready to go. Everything's red to go. Okay, here we go. So watching the dim bulbs, watching the meter, watching everything. Okay, no light. Yeah, the light came up. Oh, the meter's going up. The meter's going up. Now that could be this adjustment here. Yeah, that's the adjustment. This is working perfectly fine. Okay, settling down. So there's probably a big difference between the B plus and the screen at the start of things. Very interesting. Okay, what about some sound here? How about the speakers not connected? How about that? That's one thing I didn't check. I checked it earlier. Switch here. I was fiddling with this. Okay, I'm sure it's just the I haven't done the speaker connections right. What has happened? Why no sound? Uh-oh. The alarm's ringing in my head. Why no sound? Why no sound? Well, no sound because we're at 74 volts. That's why there's no sound. Okay, let's go back here. 74 is just too low. Volume down. Watch the meter. Ooh, look at the light up now. Unfortunately, you're getting another hot spot there on the camera. Come on, make some sound. What's the matter? Where are you? There we are. Just got this done wrong. Okay. I have to turn this up pretty darn high. Got the signal generator connected. That was probably the why we're not hearing the signal generator. There we are. Watch the meter now. Look at that. Okay, zero the meter properly. If we can. We cannot. Oh, it's not really changing at all. Could be B plus and screen are just about the same right now. Okay, then that would become like a sensitivity thing. Tune in. Oh. Well, so maybe not quite right here. Good. Wow. Okay, let's hit this guy with a stronger signal. Okay. I'm going to move with my arm right in front of the camera. Give me a moment. Let me put it like this. Okay. First I'm going to check the calibration over here. It's way low. There we go. What have we got? Factor of 10. Red. Well, that's fantastic. And I won't go up another level because it's stupidly loud. We'll go down. It's very low now. Maybe one of those resistors isn't quite the right value, but there we go. Wow, that was nothing. Why did somebody cut that wire? What were they thinking? Fantastic. And you know what? I'm going to have to end it here today because I've been distracted too much. You hear a cat crying for me already. Oh my gosh. Fantastic. That's great. Look at the light, light, light. Beautiful. Okay, I think I need one more test, and that's a real world test. So I've hooked up my outdoor antenna here, and I've set it to band 3, and we're up around 9 megahertz. Let's watch the meter.
Called alien invasion will make people desperate for safety at any cost. The freedom to live and worship as the conscience dictates will become a thing of the past. Many lives will be lost during this series of events, and when the mark of the beast is enforced, there will be martyrs. Each event prepares for the next crisis. In one long-last call of mercy to repent, the Yahweh is not willing that any should perish, but that all should come to repentance. Shortly following the events described in Revelation 8 and 9, the 7 last plagues will be poured out. These plagues and the earlier trumpets will wreak havoc on the earth and cause unprecedented destruction and misery.
Oh man, that's really bad. That's a bad prediction. Well, that's fantastic though. The meter's working. Real world test. Thumbs up. Excellent. Excellent. Yeah. Stop the video now. Now's the time to stop the video before it's too late. So thanks again. Thanks a lot for watching. Thanks again a lot for watching. I'm so excited. See ya.